So here guys, the question is to determine the horizontal and vertical components of forces, which depends at A, B, C, exert on member ABC, the whole member ABC. Which means guys, I need to find what are the forces exerted on A, B, and C on the member ABC. And this means I should isolate the member ABC from the whole frame and study what are the forces exerted on this member. So let's do it. Okay, so guys, the question is to find all the forces exerted on the pins A, B, and C. So what I want to do, exerted on the pins A, B, and C by the member ABC. So what I want to do, I want to isolate the member ABC from the whole frame. Okay, so basically this will be the member ABC. Let's say this will be A. What do I have at A? I have a roller. This will be B. And this will be C. Now, what are the forces exerted on the members, on the pins ABC? What are the reactions or what are the components of the forces? This is what I want to do. Now, guys, before doing this, remember that at A, I have a reaction only, vertical reaction, because this is basically a roller. So I only have a Y here, I don't have a X. At C, I have two forces. Let's say this is Cx. You can assume any direction, and then you can predict if your direction is correct from the sign. And this is Cy. Basically, B belongs to the member ABC. I know that I did not separate B from the member AB or from the member BC, but I separate B from the members B, D, and B. Now guys, I want you to pay attention to this note. In the definition of the frame, we said that the difference between the frame and the truss is that I will have at least one member where there is an external force that is not applied on the joint, like the member CD, like the member DE. So here guys, I have two members where the forces are not exerted at the joints only, but I have another force exerted on the member itself. So this doesn't mean that inside a frame, I can have another type of members like the two-force member. I could have a two-force member inside the frame, and this will still be a frame, not a truss, because I have another member that is not a two-force member. So like what here, guys? Like the member BD. If you take a look on the member BD, guys, you can see that there is no external force on this member, which means, guys, that this is a two-force member, which means what? This means that the forces on B and D on the member BD are axial. Okay? So the forces are axial of the same direction of BD, which means, guys, when I separate ABC from BD, there will be an internal force that will show here, which is the force caused by member BD on the pin at B of the member ABC. So I will show, guys, this force in green. This is FBD. So why I choose this direction, which is the direction of BD, which is this direction here? Because in fact, this is a two-force member. In the two-force member, I know that the forces are along the member, so they are axial. So this is FBD. Now, what about FBE? FBE is also a two-force member, which means the force at B on the member BE will be also axial. So guys, I will assume also that this will be the direction I'm sure here, guys, that FBE will be axial, which means it has the same direction of BE, and that's why, guys, I'm tracing this line, which is the blue direction of BE. Okay, so basically, these are the forces that I need to find to answer my question, because the question is only to find the forces exerted on the pins on which member? On the member ABC. Okay, so these are the forces on the pin on the member ABC. Now, how to proceed? How to find them? Basically, guys, I can do first of all the sum of moments around B. Because if I do the sum of moments around B, and as you can see, AY will vanish, FBD will vanish, FBE will vanish, as well as CY, guys. So I only have the force CX. The sum of moment around B will give me that the moment of Cx is also equal to 0, which means that Cx is equal to 0. And from here, I get rid from the first unknown. Then, guys, how to find Cx, Ey, Ay, FBD, and FB? Basically, guys, in order to find Ay, which is the reaction at A, I can take my frame as my free body diagram. So you should take a deep look, guys, on your frame. If I only have 3 reactions like this case, this is AY, this is, for example, 2 reactions at E, then I can take the whole free body diagram and find these reactions. What differs this frame from the previous frame in the previous example is that the previous frame has 4 reactions because it has 2 pins. So I cannot take the whole frame as my free body diagram to find this reaction. Now here, I can do this because in fact I only have 3 reactions. So what I want to do, guys, I will not write the 3 equations and solve for all my reactions. I don't need them. I only need the reaction at A. So I will take this as my free body diagram, and then I will say the sum of moments around E is equal to 0, so that I get rid from these 2 reactions. Then, guys, what I will have, AY times what? AY times the distance from A to E, which is basically 1.5 plus 2, 3.5. And then, guys, this 400 in the negative direction compared to AY, you can take another positive direction, times 2. And then I have minus 300, which is this one, times this distance right here, 3.5. Then I have another force, which is also 300, so minus 300, but times 1.5. And this will be equal to 0. So from this equation, guys, I can find AY, which is about 657, I think, Newton. So here, guys, I know AY. I still have 3 unknowns, FBE, FBD, and CY. So how to find them? Basically, guys, I can go to the member CD. So I will keep B, guys, to the end because I have 2 forces in it. Now, the joint C here, or the pin C here, is also connecting member ABC with member CD. So if I take the member CD, what do you think, guys? Is CD a 2-force member? Of course not, because I have here 400 Newton. So guys, if I separate CD, I will have a completely opposite force to the CY. Since Cx is here equal to 0, then this Cx will also equal to 0. This is Cy, it is downward here. And then guys, of course, I will have two reactions at D, but I don't have to find them because the question is only asking about the forces on ABC. So guys, what I want to do now is to find the CY by doing the sum of moments around D. So if I do the sum of moments around D in this member, this is equal to 0, then I can find Cy. And here Cy will be negative, okay? So Cy times 3.5 plus 400 times 2 will be equal to 0, which means that Cy will be negative, I think 229, and this means that this Cy should be downward. And it is equal to 229. So this will be Cy, and it is equal to 229. So guys, I only have two remaining unknowns, FBD and FBE. So what should I do, guys? I have a member that has only two unknowns. Of course, guys, I can apply the sum of fx is equal to 0 and the sum of fy is equal to 0. And then I can find FBD and FBE. Okay, so let's apply sum of fx is equal to 0. So what do I have? Basically, I don't have Cx, I don't have Ax, so I only have the projection of FBD and FBE, which means, guys, that the projection of FBD on X should be equal to the projection of FBE on X. And basically, guys, I can predict this. This means that FBD is equal to FBE because, in fact, I have a symmetry here. So I can predict that the projection of that FBD is equal to FBE directly from symmetry. So this is first. So from sum of x is equal to 0, I can say that FBD is equal to FBE. And then from sum of fy is equal to 0, of course I should find this one. This length here is equal to radical 2.5 squared plus 3.5 squared, which is about 4.03. And then I can find sum of fy is equal to 0. I can say that minus FBD or minus F, because they are equal, times 2.5 over 4.03 times 2 minus 229, which is C9, plus 657, which is AY is equal to 0, and then I can find F. Now, since here the question is to find the horizontal and vertical components of each pin, you can of course find By because Bx will be equal to 0. You can find By as the resultant force of these two forces in the vertical direction. Thank you.